So now let's build out our contains method. So I'm going to bring up a tree here, and I'm going to do the same thing I did with insert, where I write out all the steps, and then we code it. So let's say that we're trying to find out if this tree contains the number 27. Well, if we're looking for the number 27, we're going to start at the root, and either we're going to have a tree like this that we iterate through and see if it's there or not, or root is equal to null. So the first thing we'll do is we'll just say if root is equal to null, we're going to return false because that is not in the tree. So that'll be our first step there. If root equals null, return false. Otherwise, we have a tree that we can go looking for the node. If the tree does have items, we're going to need a temp variable and say we're looking for the number 27. We're going to compare the number 27 to each node until we find one that is equal. We'll move this back up to the top, and we can say let temp equal this dot root. So the other possibility is that we're looking for a number that is not in the tree. So let's say we're looking for the number 17. We're going to go to the left, and that's not equal to 17. And we go to the left again, and that's not equal to 17. And we go to the left again, and now temp is equal to null. So binary search trees are null-terminated lists. And as we're moving through this, we already know that we're going to need a while loop, but now we're going to say while temp. So basically, while temp is not equal to null, we're going to keep going. But if we hit null, we know that that number is not in our tree. So inside the while loop, we can say if it's less than, we're going to move temp to the left. If it's greater than, we're going to go to the right, and then there's a third option. It could be equal to, in which case we would return true that that item is in the tree. And if temp ever becomes equal to null, it'll break us out of this while loop and we'll return false. Okay, so let's take these steps and build out our code. I'm going to move these to the bottom like this, and we'll start building our contains method. We're going to pass it a value, the value that we're looking for. And step one, if root equals null, return false. That's this situation where root is just pointing to null. It's an empty tree. And we'll say if this dot root equals null, return false. We'll take that off of our list. Then we'll say let temp equal this dot root. We can actually just move that up because that's as the code would be written. Likewise, while temp, we can just move that up because that's how you would write your while statement. We will need the curly braces here, so I'll bring those in. If it's less than, we're going to go left. So we'll write an if statement. If the value is less than temp.value, we're going to say temp equals temp.left. So the value there is the value that you passed the contains method. If it's less than temp.value, the item that temp is pointing to, then we move it to the left. So to put this another way, we are comparing the value that we pass the contains method to the value of the node that temp is pointed to. And if it's less than, we're going to say temp equals temp.left, which moves temp to the left. And we can remove that from our list and say else if it's greater than, go right. So that is to say that the value that we pass the contains method, if it is greater than temp.value, we're going to say temp equals temp.right, and that moves temp to the right. And we can remove that item from our list. Then we say else if it's equal, we're going to return true, and that code looks like that. We can remove that from our list. Otherwise, if temp is ever equal to null, it'll break us out of our while loop, and we will return false. And we can just move that up. Okay, so that is all of our code for that method. Okay, so I want to walk through this code to make sure that it's clear what all this means. Obviously, if we have an empty tree, we're going to return false. And let temp equal this dot root, that just is going to start temp at the top. And I want to focus in on the rest of the code here, the while loop on down, and just walk through a couple of examples of how we would loop through this. So I'm going to bring up a tree, and we're going to look for, in this case, the number 27. So temp is starting up there at the top, and we would say while temp, and temp is pointing to a node, so our while loop will run. And this if statement, the value is less than temp.value, so we're going to say temp equals temp.left, which moves that down. Then that's going to cause us to run our while loop again. This time the number we're looking for is greater than. So else if the value is greater than, we're going to say temp equals temp.right, which moves that down to there. That's going to cause us to run the while loop again. In this case, it's equal, and we're going to return true. So let's look at another scenario. Let's move this back up to the top like this, and look for the number 17. We'll say while temp, this is less, and we're going to move it to the left like this. That causes us to run our while loop again. It's less than again here, and that's going to move us to the left. And now we're going to run the while loop again. It's less than again, and we're going to go to the left again. But now it's going to make temp equal to null. And when we go to run our while loop, this equates to false. So it breaks us out of this while loop, and then we return false. Okay, so let's bring the rest of our code back in here. We'll look at this in a moment in Chrome DevTools, and then we will build out this tree, and we will look for the number 27, just like we did here. That should return true. And then we will look for the number 17, just like we did here as well, and that should return false. Okay, so let's flip over to DevTools. And this is our contains method here. And then I'll just scroll up a little bit. And this is where we build the binary search tree that was in the diagram that I just showed. Okay, so I'm going to zoom out here. And I'm going to run this. And this is our binary search tree. And you can see 47 is at the root here. I'm not going to go through opening all of these. I'm just going to clear this. So the first one I'm going to bring up here is mytree.contains with the number 27. Press enter, and you can see that that's true. And then I'm going to do it with the number 17, and it returns false. All right, so that is our method for contains.